Welcome, viewers. Today we'll be looking at how to find the relationship between the following algebraic expressions, given that x plus 1 over x is equals to 3. You are admonished to watch it to the end so that you get full value for this video. And also there is an example that will apply this relationship. Before we proceed, it will be appreciated if you can kindly subscribe to this channel and also hit the notification bell so that you are promptly notified of videos that are uploaded on this channel. So we have been given the algebraic expression x plus 1 over x equals to 3. X plus 1 over x is equals to 3. But what we will be doing is to get a generic form of other forms of algebraic expressions. And we'll be using this particular algebraic expression, x plus 1 over x, as a basis. And so we'll say let x plus 1 over x be equals to n. What we are indirectly saying or directly saying is that 3 will now be represented as n. And that is because we want to get a generalized form of the algebraic expression for other related expressions. So what we are saying now is, if we square both sides, we now have x plus 1 over x all squared is equals to n squared. Remember we said we're representing 3 to now be n. So when we square both sides, let's look at the left-hand side first. We have x plus 1 over x all squared, and that is simplified as x squared plus 2x times 1 over x plus 1 over x all squared. And of course, is equals to n squared on the right-hand side. Now, remember the expression where we have a plus b all squared is simply a squared plus 2ab plus b squared. And of course, that's what we have on the left-hand side, and we have n squared on the right-hand side. Now, if we simplify this further, we have x squared plus 2 plus 1 over x squared, and that is equals to n squared. Notice that the x here cancels the x here, and we're left with 2, and that's where we have this 2 here. Now, in simplifying further, we have x squared plus 1 over x squared is equals to n squared minus 2. So we have successfully found the relationship for x squared plus 1 over x squared, and it is equals to n squared minus 2. Remember, we had x plus 1 over x is equals to 3, and we did establish that n is equals to 3. Therefore, if we substitute the value of n is equals to 3 in the above equation, it simplifies to x squared plus 1 over x squared is equals to 3 squared minus 2. And that further is simplified as x squared plus 1 over x squared, and is equals to 9 minus 2, and that is equals to 7. So we have successfully simplified, and we now have x squared plus 1 over x squared, and that is equals to 7. So here we'll be using x plus 1 over x is equals to 3 once again. But remember we said 3 will be represented as n. So let's take the cube of both sides, that is, we'll be multiplying by the power of 3 of both sides. Remember we said n is equals to 3. So taking the cube of the left-hand side, we have x plus 1 over x all raised to power 3. Then we have n raised to power 3 on the right-hand side. When we expand this using the binomial expansion or using the Pascal's triangle, in case you've not watched my video on the ease of expanding using the Pascal's triangle, you'll see the link at the end. So when we expand the left-hand side, x plus 1 over x all raised to power 3, what we simply have is x raised to power 3. Then we have 3x squared times 1 over x. Then we have 3x times 1 over x all squared plus 1 over x raised to power 3. And of course, the right-hand side is n raised to power 3. Now, when we simplify this further, we have x raised to power 3 plus 3x squared 1 over x plus 3x 1 over x squared plus 1 over x cubed is equal to n raised to power 3. When we simplify this further, we have x here 1, x in x squared, we have x. So when we also simplify this other one, so one of the x's will be cancelled by the x on top. So let's see what we have as the separation. So we have x cubed plus 3x squared 1 over x plus 3x 1 over x squared plus 1 over x raised to power 3 is equals to n raised to power 3. So we will just be writing out the simplification, and the simplification gives us x cubed plus 1 over x cubed plus 3x plus 3 into 1 over x is equals to n raised to power 3. Remember, we took the first value here, which is this, and then we took this second value here, this last value here, and then placed it here as the second value. Then the simplified version of this value is equals to 3x, and then the simplified version of this value here is equals to 3 1 over x. And of course, the right-hand side is equals to n raised to power 3. So we have x cubed plus 1 over x cubed plus 3 into x plus 1 over x. You notice what we did here was to simplify, or rather factorize, what we had here. So when we factorize what we have here, we simply have 3 into x plus 1 over x and bracket close. So remember that x plus 1 over x is n. X plus 1 over x is equal to n. So this expression here, we can simply call this expression x plus 1 over x. We can simply call it as n. So we have x cubed plus 1 over x cubed plus 3n is equals to n raised to power 3. So we have established that x raised to power 3 plus 1 over x raised to power 3 is equals to n raised to power 3 minus 3n. N raised to power 3 minus 3n is what we have established for x raised to power 3 plus 1 over x raised to power 3. Remember, we said n is equals to 3 as we established at the beginning for this particular scenario. So now that we know what our value of n is, we can simply impute it into the expression, and that gives us 3 raised to power 3 minus 3 times 3, which is x raised to power 3 plus 1 over x raised to power 3, and that is equals to 27 minus 9. And when we simplify that further, we have 27 minus 9 giving us 18. So that is what we have established for x raised to the power 3 plus 1 over x raised to the power 3. It is equals to 18. We will be using this expression which we had generated earlier. X squared plus 1 over x squared is equals to n squared minus 2. We will be using it to form an algebraic expression for x raised to the power 4 plus 1 over x raised to the power 4. So we will be squaring both sides of this expression, and that gives us x squared plus 1 over x squared all squared is equals to n squared minus 2 all squared. And by the time we simplify the expression, we have x raised to the power 4 plus 2 plus 1 over x raised to the power 4 is equals to n squared minus 2 all squared. As we simplify this expression, we have x raised to the power 4 plus 2 plus 1 over x raised to the power 4, and is equals to n squared minus 2 all squared. By the time we take the 2 to the right-hand side, it becomes negative. Therefore, we now have x raised to the power 4 plus 1 over x raised to the power 4, and that's equals to n squared minus 2 all squared minus 2. So this is the algebraic expression for x raised to the power 4 plus 1 over x raised to the power 4, and it is simply equals to n squared minus 2 all squared minus 2. Now remember, we had our n in this particular case. N is equals to 3. Therefore, we'll substitute the value of n is equals to 3 as appropriately and simplify it. And we will get 7 squared minus 2, and that's 49 minus 2, and that is equals to 47. So in this section, we will be given a summary of the algebraic expressions and their relationship as we had earlier established. Now, starting with x plus 1 over x is equals to n, we were able to establish further that x squared plus 1 over x squared is equals to n squared minus 2. Then along the line, we also established that x cubed plus 1 over x cubed is equals to n raised to the power 3 minus 3n. And then finally, we were able to also establish that x raised to the power 4 plus 1 over x raised to the power 4 is equals to n squared minus 2 all squared minus 2. So what we will simply be doing is solving a question. We'll be solving an example where we have x raised to the power 4 plus 1 over x raised to the power 4 is equals to 194. And from that expression, we are meant to find out what x raised to the power 3 plus 1 over x raised to the power 3 is. So let's just be reminded that we already established earlier that x raised to the power 4 plus 1 over x raised to the power 4 is equals to n squared minus 2 all squared minus 2. And if that's the expression for x4 plus 1 over x4, it also means that that expression is equals to 194. So we will equate it to 194, that is to say, n squared minus 2 all squared minus 2 is equals to 194. And by the time we take the negative 2 on the left-hand side to the right-hand side, it now becomes, on the right-hand side, 194 plus 2. That is, n squared minus 2 all squared is now equals to 194 plus 2. So now that we have established that n squared minus 2 all squared is equals to 194 plus 2, which is 196, we'll take the square root of both sides. We have n squared minus 2 is equals to 14 because the square root of 196 is 14. So we'll take the minus 2 on the left-hand side to the right-hand side. It now becomes plus 2. So we are left with n squared is equals to 14 plus 2, which is equals to 16. If n squared is equals to 16, our n is equals to plus or minus 4. But we use n is equals to 4 in this example. So now we have established the value of n, and n is equals to 4. Well, let's be reminded, x raised to the power 3 plus 1 over x raised to the power 3 has been established in this video to be equals to n raised to the power 3 minus 3n. Therefore, since we know the value of n, which is equals to 4, we will simply substitute it in this algebraic expression so that we have 4 raised to the power 3 minus 3 multiplied by 4. And that gives us, as we simplify further, as 64 minus 12, which eventually gives us x raised to the power 3 plus 1 over x raised to the power 3 is equals to 52. So we have been able to successfully solve for x raised to the power 3 plus 1 over x raised to the power 3. Thank you. Thank you for watching this YouTube video. Kindly subscribe, like, and share.